Hello class, I am going to work an example problem for Unit 3. I learned after the last couple of semesters that some of the examples I had made were not clear enough. So I have built two new examples here. One is similar to Chapter 10, Exercise 2, and one is similar to Chapter 10, Exercise 4. I have made them very, very similar this time, and I will try to call out a couple of things that I've seen some past students struggle with. I want to make sure I fill that in. So in the book for Chapter 10, Exercise 2, it's got information similar to what you see here on this spreadsheet. Now I am going to make this a little bit bigger. This might be hard to see in the video for you. There, that should help. Yeah, I'll have plenty of room to do it that way. So you run a company that resells a variety of products. You put a bid request out to 6 suppliers for 6 different items. The table below shows the price quotes you got back from each supplier for each item. Note that some of the suppliers declined to quote some items. First, solve the supplier plan. You want to come up with the lowest total cost to buy the items that you need based on the demand that you know you have for each item. That is the first step. For Part B, we're going to add a constraint that says we're not allowed to spend more than $2 million with any single supplier due to capital financing requirements. This is a thing. So depending on what industry you go into, sometimes your investors or your banks will say, I know you've got $3 million to spend. We don't want more than $2 million spent with any single supplier. We want you to spend some of your money with a secondary supplier so you cultivate an additional relationship. It's good business practice. It's diversity of acquisition. For Part C, we're going to add another constraint that you don't want to buy more than $30,000 of any single item from any supplier. Yeah, theoretically, there's a reason for that, but I'm adding that other constraint just so you can see how it works, and you can see a little bit more of how Solver works. So that one's kind of arbitrary. So first, I've got this data, and I've got this information. So I can see that item number 1, who knows what this is, printers, screwdrivers, shoes, I don't know what it is. It's an item I need to buy, and supplier 1 has quoted me $99.60. Supplier 2 decided not to quote. Supplier 3 quoted $73.61, and so on. And I need to buy 40,000 of this item in order to satisfy my demand. When I put this into Solver, and part of what you want to do with Solver is don't try to solve this problem yourself. Instead, create a relationship between the data, a few formulas, and what you're trying to optimize, and let Solver solve the problem. So the first thing you have to realize is, since this is a cost problem and I'm trying to minimize my cost, how is Solver going to interpret a blank cell? It's going to think that's a 0. Therefore, it's going to think, I'm going to make this bold, and I'm going to make it red. It's going to think that item number 1 from supplier 2 is free. Okay? We don't want Solver to think that. So instead, the best practice from a data set, if I'm doing a minimized problem, is to put a dummy value in here that is so out of range that Solver understands that supplier number 2 does not want to sell me item number 1. I'm going to put in $99,999. Okay? So this is telling Solver, in order to get supplier 2 to sell me item 1, I have to pay a ridiculous amount of money for it. So Solver will know supplier 2 doesn't really want to sell this. Using a number like this accomplishes a second thing. It's easy to spot in my data table. This data table is small. It's 6 by 6. Those of you who might go into data analytics for your careers, you could end up working with data tables that are 10,000 columns wide and 200,000 rows deep. If you're doing that, you want to be able to use the search and find function very, very easily. Okay? So if I was doing a minimized problem, I would use a number like positive $99,999. If this was a different kind of a problem and these were numbers that I was wanting to maximize a profitability, let's say these are profit margins by item, I might choose to tell Solver that this thing has a profit margin of negative $888,888. in order to tell Solver that this is a highly unprofitable item. Okay? So in this case, because I'm trying to minimize my total cost, I am going to use the positive large number that's easy to spot, and I'm going to put that, whoops, in each one of these blank cells. And you can see I've done something here. I have made them bold and red. That is so it is easy for me to see, easy for me to find, and I can glance at this table and recognize I got all the blank cells. A mistake I saw several times 2 semesters ago, students put the dummy values in correctly, but missed one of them and left one blank cell on a homework problem. It's okay, I can catch that. I'm not going to take off a bunch of points for that. But if you'll make it bold and red, it's easy to find. Second, now I have to decide what are my decision variables. My decision variables are how much of each item I want to buy from each supplier. That means I'm going to have a matrix that is the same size and shape as my data matrix, as my decision variable matrix. So I am going to highlight this whole thing, okay, using Command C. I'm going to Command V, and I'm going to come over here. I'm going to see these are my decision variables area, and I got to do a little bit of formatting here, okay, but these are going to end up being my decision variables. They were dollar amounts, but I'm going to take that away. I'm going to change it to be a number. I want to have commas be visible. I'm going to get rid of the decimal places for fun, okay. I'm going to get rid of the red. I'm going to get rid of the bold, okay. And now this is going to end up being quantities of each item that I want to buy, okay. So since these are my decision variables, a practice I like to do is highlight my decision variables in yellow, and then I put a big thick outline around them so it's easy for me to see that these are the things I'm going to change as my decision variables. Okay, I know that my demand numbers are in the thousands, so I'm going to just put the number 2000 in every cell, okay, as dummy values. That will make it easy I'm going to do a little paste special here, and I'm going to do values instead. I wanted to keep my formatting like it was. I like my formatting. There we go. So when I build formulas in a minute, I'll be able to tell if my formulas are working. Okay. Now, up here, the data table told me that I've got a demand of 40,000 for item 1. Well, here in the decision variables, I'm going to have some supply amount that is the sum of the supply of each one of the suppliers for item 1. So easy to tell, my formula is working correctly. I've got 6 items at 2,000 each, 12,000. That sounds correct. So I'm going to copy that formula across, boink, and there we go. Now, this is going to be something I want to include in my constraints in a minute. So I'm going to highlight it blue so I don't miss it, okay? I do that frequently. I'm not super consistent with it, but if I want to make sure I don't miss a constraint, I'll highlight constraints in blue to make sure that I catch those. And that way I will get them populated into Solver, and Solver knows to use them. Okay, next, I got to figure out what my objective is, right? Okay, my objective is a total cost. And I know I want to minimize that total cost. So I'm going to come here. I'm going to highlight my objective in green, and I'm going to do a nice thick outline around it. And I know my objective is going to end up being in dollars, so I'm going to format it as accounting. But now I got to put a formula in there. I've got to create a relationship between this data table of costs and this decision variable table of quantities that calculates my total cost for procurement. Now, I've already done this in another video, but so you pick up on a concept. You understand that if I take the cost of item 1 from supplier 1 and I multiply it times the quantity of item 1 from supplier 1, and I add to that the cost of item 2 from supplier 1 times the quantity of item 2 from supplier 1, and I add to that the cost of item 3 and multiply it times the quantity of item 3 from supplier 1, and I do this over and over again for this whole table, that will come up with the cost that I have for these quantities at these prices. This is tedious and it is error prone. So I'm going to hit escape instead, and I am going to use the formula sum product. Okay? This is not the same as the sum formula. So up here in the supply, I use the sum. It simply adds together these items. The sum product does exactly what I just showed you. It adds together the product, or the multiplication of the item in cell 1 times the item in cell 1 in the next matrix, plus the item in cell 2 times the item in cell 2 of the next matrix. So if I use the sum product formula and I highlight all of my costs, this matrix, comma, and I highlight the quantities matrix, and I close that out, and I'll give you a second to look at this so you can see the format. That will do the exact same thing as that tedious exercise I started to show you a minute ago. I'm going to have to make this column wider because that number is too large. So we're over $1 billion. Fantastic. I assume that when we optimize this, that number will get smaller because at the moment, we're still buying 2,000 of these things that cost almost $100,000 each, and I don't think Solver will want to do that. Okay. Now, as surprising as this is going to be to some folks, this is it. This is the model. You're finished. That's all you have to do to come up with a purchase optimization matrix. That's part of why using Solver in Excel is such a powerful tool. So now I'm going to go to Data. I'm going to click on Solver, and I blanked it out earlier, and I'm going to say my objective is this right here, this total cost. I want to minimize it by changing all these quantity cells. So everything I highlighted in yellow earlier is part of my variable cells. The book refers to them as decision variables. I try to call them decision variables. Depending on which version of Excel data solver you're using, it will simply call it a variable cell instead of a decision variable cell. It means the same thing. Subject to the constraints, I need to add a constraint. I know I want my supply to be equal to the constraint of my demand. Okay? Now, a best practice when adding constraints is put the calculated item, the supply, the thing that's calculated from a formula that you wrote, over here on the left-hand side of cell reference. And on the right-hand side, the constraint, refer to the cells that have the scalar values of the constraint. Solver will work if you flip those around, most of the time. If the formulas are complex, particularly if you're on an Apple product, sometimes it can cause some funny behavior out of Solver. It's not the main reason you do this. The main reason you do this is for the sake of consistency. Most of the models we're building in this class are fairly small. Later, if you build a large model with lots of constraints, and you're consistent about the thing I calculated is on the left, the scalar value I want it to comply to is on the right, and you always do that, it makes it far easier to troubleshoot this model. Okay? Now, I'm going to change this to simplex LP because this is a linear program. This is a linear problem. That's what we're doing in Unit 3 is linear stuff. Unit 2 had some things that were a little more non-linear, but this time it's linear. So I pick linear and I click solve and I hit OK. And I look at it for a minute. And did it choose to buy anything from those high-priced items? No, it doesn't look like it. We didn't buy anything from supplier 6. It's interesting because supplier 6 has some prices that looked reasonably attractive, but not the lowest. So this stands to some reason. Okay? Now I'm going to do something here. I'm going to click Solver. I'm going to run Solver again. See if it changes. Sometimes, if the problem has to iterate a bunch of times, Solver will not get all the way to an optimum solution in one pass. But this looks good. The supply matches the demand. I've got a good price here, $7.6 million. I feel good about that. Now I'm going to do part B. So I'm going to press Control, and click on a tab name here. I'm going to move or copy this tab. I'm going to create a copy. I'm going to put it before this one. Boop. Okay, and then I'm going to rename this. It's exercise 2, part B. So on part B, add a constraint that you're not allowed to spend more than $2 million with any single supplier. Okay, so I'm going to add a column over here of total spend. Okay, and I'm going to take a moment here and bold it, and I'm going to center it in the column, and I'm going to calculate how much am I spending with supplier 1. Once again, I'm going to use the sum product formula. I'm going to highlight only items from supplier 1, comma, and only prices from supplier 1. Close it. Hit enter. Okay. I'm now going to format this as a dollar figure. I'm going to get rid of the decimals. The pennies are not that interesting. And I'm going to copy that formula down the page. Interesting. So it says I'm not allowed to buy more than $2 million from anybody. Well, right here I can see a problem. Supplier 3, I bought $4 million worth of stuff. Okay. Now I'm going to add down here that 2 million number. And I'm going to label it max allowed. And I like doing little arrows. People think I'm silly with that. But I'm going to highlight that blue, like I said I sometimes do. I'm going to make that dollars. I'm going to get rid of those decimals. And I'm going to make it bold. That's a constraint, okay? So I need to add this constraint to my solver. This is easier than some folks make it. So now I'm going to click Data again. I'm going to click on Solver. And to add this, my cell references, I'm going to highlight all 6 of these cell references must be less than or equal to this 2 million constraint. You do not have to point to each one individually. Highlighting that and doing that will do the job. Okay. Some people are more comfortable putting a max formula in there under the total spend. That's fine. Okay. If you like that better, if it makes it easier for you to troubleshoot your model, it's your model. Personalize it. But you don't have to. Now I'm going to click Solve. Okay, I'm going to click OK. Now it got everything under 2 million. Now we're at 7.7 million. So you can see now in order to spend less than 2 million with each person, we've de-optimized our total spend. We're now buying something from supplier 6. It forced a little more supplier diversity. So where previously we're buying everything for item 1 from supplier 3, we're now buying it from 3 different suppliers. Now I'm always skeptical when I add a constraint like this. So I'm going to run Solver a second time. Nope, it looks pretty optimized. So now we're going to add part C. No more than 30,000 items from anybody. So looking through here, I can see, yep, supplier 3, 34,000 items. Supplier 5, 32,000 items. So yeah, I'm going to add this on. I could just add it right here, but for the sake of some consistency, I'm going to copy this tab. I'm going to put it before the other problem. Create a copy. Boom. I'm going to rename it. Okay. And I'm going to say this is part C. Okay. Now, if I was turning this in as homework, I would be adding some comments. So like on part B in here, I would have comments. And I would say something. And the way I like to do comments, I like to take a bunch of cells and use this little widget here that merges a bunch of cells. I'll align it to the top and to the left. And for my comments, I'm going to say total spend was about 7.6 million before. to spread between vendors. Total spend is de-optimized to 7.735 million. Okay. There is more vendor diversity. I'm now buying item 1 from 3 vendors, not 1, and so on and so forth. Whoops. And you click the wrap button so it'll wrap. I want several sentences, a nice solid paragraph interpreting what I think I see here, why it's a good thing. Okay. While spending more total may not sound like a good thing, cultivating many possible vendors is often a good thing, and so on and so forth. So let's say hypothetically that supplier 3 is based here in the US and I'm a US based company. Let's say hypothetically the supplier 6 is out of Southeast Asia and there is a particularly rough monsoon season this year and Southeast Asia is having a hard time meeting their shipping schedule because the ports keep getting closed because of storms. Well, the fact that I'm buying most of my stuff from that vendor is not a disaster because I can choose to pivot and buy more from a different vendor instead. So this is a real world business decision that gets made. Now for part C, we have a new constraint that we need to add. And I'm calling it total eaches. This time, instead of the sum product, I'm just going to use the sum. How many items am I buying from each supplier? And you can see here, I've got more than 30,000 here, more than 30,000 here. And okay, this is not the most beautiful layout, but my max allowed, according to the problem, is 30,000. Add a comma to that. I'm going to get rid of my decimals. I'm going to make it bold. I'm going to highlight it in blue so I don't forget to add it to my solver, and that's that. So look here, we're 7.735 million. We've got 3 vendors right at 2 million and 3 vendors that are about $500,000 each. Now I'm going to go to data. I'm going to click on solver. I'm going to add a constraint for the cell reference. I'm going to highlight these eaches I just calculated. Must be less than or equal to that 30,000 that I said I have to have. I'm going to click OK. Click solve. Say OK. I'm going to look at it for a second and see if it makes sense. And I will run solver again. But you can see we've gone up a little more. We've de-optimized our total cost a little further. But we've driven, in some cases, even more vendor diversity. But in some others, we've actually lost some vendor diversity. But we have spread our spend out. Only one vendor is at the 2 million. A couple more are now down at around 1.8 million. One is still at $500,000, and two are at $500,000. Another one's approaching $1 million. Okay. Click solver. I'm going to solve again. Yep, and that looks pretty well optimized already. Okay. So that is an example of how you would work Chapter 10, Exercise 2. Moving on, Chapter 10, Exercise 4. It is a combination problem of you have multiple manufacturing locations and multiple ship-to locations. In this case, you own the company, and you own all 5 of these manufacturing locations, and you own all these distribution centers, or you work with these distribution centers, or the ship-to locations. The cost to ship your parts is listed in the table below, and this may be per item. So let's say you're shipping nuts and bolts, and it costs you $1.25 per box of bolts to ship from manufacturing location 1 to ship to 1. It costs you $2.25 to ship from manufacturing location 1 to ship to number 2, so on and so forth. Very similar to the prior problem. It's a distribution question. Distribution questions and procurement questions are parallels for each other. They both work the same way. But in this case, you've got an added layer of complexity. You have the cost to produce at each one of these locations as well. We've got to factor that in. But once again, we're trying to minimize cost. So we're going to start in a very similar way. I need to come up with what are my decision variables. To make sure that I make this matrix the right size, I'm going to do just like I did before. I am going to grab this, I'm going to copy it, I'm going to come down here, and I'm going to paste it. Okay? So these are going to become quantities instead of dollars. So I'm going to change this to a number. Okay? We get rid of those decimals. I can see that my demand previously was in the thousands. So my supply, I'm expect to have in the thousands. So I'm going to put that 2,000 in here again. It seemed like a pretty good number to me. I'm going to add a comma in my formatting. Get rid of those decimals again. Okay, now, some of you are already watching this video, and a couple of you are getting nervous because you've picked up on something. Even though it's my own company, I don't have a good shipping lane. So I don't like to ship from manufacturing location 3 to ship to location number 2. To make sure Solver knows that I don't want to use that as part of my solution, what do I want to do? I want to put in a great big number that tells Solver that this is not available for optimization. That's not a 0. That's not free shipping from manufacturer number 1 to ship to number 4. That is, I don't want to use that as a solution. Okay? Now, back to our decision variables. I need to put a formula in here. I use the plain old sum formula to sum up how many of each item am I going to ship from each manufacturer to my ship to number 1. Okay? I'm going to copy that across. And this is now my supply to each ship to location. Okay? I'll highlight that blue. That's one constraint. Next, second, I have a manufacturing capacity. So manufacturing location 1 can only make 15,000 items. Manufacturing location 2 can only make 21,000 items, and so on and so forth. So I have a capacity constraint as well. So I'm going to add up how many of each of items am I asking manufacturing location 1 to make. I'm going to put those in, and this makes sense. So if I'm shipping to 7 locations at 2,000 each, that's 14,000, 14,000, 14,000. Looks like my formula is working correctly. Okay? Give you a second to digest a little bit. Now, what's my objective? My objective is to minimize a total cost. I have a total cost. I want to minimize it again. Okay? And I'm going to do this twice. Okay? So you can see the formulas 2 ways. I'm only going to use the most efficient version of the formula in the solver, but I'm going to show this to you. So my total cost is made up of 2 things. Okay? I have a shipping component and I have a production component. To make this easier to visualize, come back up here. Let me highlight my decision variables in yellow. So the yellow ones are the ones I'm going to let Solver change. Okay? So shipping, just like the procurement problem, if I say some product of every item, the eaches that I do from and to each location, with the cost of each item from and to each location, that's the total cost for the shipping component of my business. Okay. I'm going to make that column a little wider. $800 million. Again, I assume this will get better because at the moment I'm still choosing to ship things that cost $100,000 to ship that really only cost $2 to ship. Okay. There's a shipping component. There's also a production component. Okay. So the amount of item I produce at each location has to be factored with this cost of production. Okay. So I could use, again, a sum product of how much am I asking each manufacturing location to produce times how much does it cost to produce each of those locations. Leave that highlighted for a second so you can see it and digest it. I'm going to hit enter. Okay. I'm going to format that as $1. Get rid of those pennies. And then there's a total. Okay. That is the sum of those two items. Okay. At the moment, you can see that the shipping costs dramatically overwhelm the production costs. That's partially because the formulas are still using those very large numbers. So this is the objective. Okay. I'm also going to show you, in order to get to this total objective, and this is the one I'm actually going to refer to in Solver, you don't have to do that in two pieces. You can. If you are more comfortable going ahead and highlighting this one in green, put a box around it so you can find it again easily, and pointing Solver at that one, go for it. It is your model, personalize it. What I'm going to do though, just so you can see how clean this is to do, is I'm going to say some product of the shipped quantities by the from and to locations, sum producted with the costs by locations. I'm just going to add to it the other sum product of the produced by location times the cost produced by location. Okay, leave that highlighted for a second so you can see it. Hit enter. Clean that formatting up, and you can see that that is the exact same 802 million that I came up with a second ago, doing it in two parts. Okay? Both formulas get to the same solution. I like this, it's a little more elegant. If you like this, go for it. Okay, now that's it. That's the model. This is everything Solver needs to come up with a solution. And I'm going to come up here and say data. Click on Solver. I'm going to set my objective. Is that one down there that I picked. I want to minimize it by changing the quantities in all these decision variable cells. And I have some constraints. I'm going to add to the constraints that my supply, the calculated one that I came up with, must be equal to the demand, the scalar numbers that I entered. I'm going to hit add because I have another one. The calculated capacity, the calculated manufacturing by manufacturing location must be less than or equal to the scalar constraint by location. Click OK. And I'm going to, change this to linear. Click Solve. I'm going to hit OK. It looks like all the supplies got all the way to the numbers, and it looks like all the capacities are within limits. Very cool. So this might be the real answer, but anytime there's a little bigger problem like this, I'll run Solver a second time. Click OK. All right. Now, the advantage of doing it in two parts, shipping and production, is that when it comes time to add your comments, you can add the clever comment of, hey man, shipping is a drop in the bucket compared to production costs. So why would I ever work on improving my shipping costs? Well, you're not wrong. Okay. You would want to focus on the thing that changes your outcomes the most. So I'm going to merge those, hit wrap, change the alignment, change that. And in my comments here, I might make a comment about manufacturing location 5 is not used at all. Locations 1 through 3 are at their total capacity, so on and so forth. This is probably because production costs are far higher than shipping costs, and location 5 has the highest production cost. and then keep typing. I'm showing you 2 sentences. I would expect you to do 4 or 5 or 6 sentences here. Really digest the model and come up with some real comments. Now, I didn't have it in the statement of the problem, but just for fun, we are going to do a part B here, okay? We're going to move it to the end. We're going to create a copy. I'm going to click OK. I'm going to rename this, and I'm going to say part B, okay? And for part B, oops, sorry, y'all. If you want to carriage return down on an Apple, you press and hold the Option key while you hit return, and you can carriage return down. What if capacity at manufacturing location 2 drops by 15%? What if cost at location 1 goes up by 25%? What is the new solution? Okay. New prod costs. Okay. And I said that what if cost at location 1 goes up by 25%? So it's going to be this one times 1.25. Okay, there's my new costs. I suddenly feel like I've got to apologize. I didn't format that as dollars earlier. Violated one of my own pet peeves. The other ones did not change, so we're going to go there. When we do a part B, you do not have to do this. Me personally, I like to show the original data and show the new data. It makes it easier to add my comments below. Okay. Now my capacity constraints are changing too. New capacities. And what happened? My capacity at manufacturing location 2 drops by 15%. So my original capacity minus that capacity times 0.15. There we go, where I could have multiplied times 0.85, but I like doing it that way. So my new capacity is 17,850. All the rest of my capacities. Oops, I'm making a mistake here. Y'all see me making the mistake? I hope so. This doesn't go here. It goes here. All right, so my capacity, my 21,000 drops by 15% times my 21,000, or 17,850. My other capacities remain the same. Sorry about that. See there? There's proof. Even with a PhD and being good at this stuff, you can make a mistake. Okay. Now, so I don't forget to point this at the new places, I'm going to highlight these in a different color of blue than I used before. Okay, so these are the new things I'm going to refer to in Solver. So I'm just going to change these. Okay. So everything else remains the same. I just made those 2 adjustments. We were at 2.507 million, we're at 60,000 in shipping, about 2.4 million in production. If there's a multi-part problem, the biggest thing about your comments is going to be, how did the total solution change based on those new constraints? So I'm going to say data, solver, and I'm going to come over here, and this D26 through J26, that's my supply and demand constraint. I don't need to change that. Okay. Ooh, I just realized something. I've got to change what formula this is referring to. So I'm going to close this for a second. So this capacity is in Solver. This cost of production is out here in a formula I built. So I'm going to change what I'm referencing in the exposed version, and I'm going to change what I'm referencing in the elegant one. Okay. And again, you do you on how you want to do that. So now I'm going to go to Solver, and this one, change this, and so I have a cell reference here. So my calculated quantities are here. My constraints were here. Now I have my new capacity constraints. where manufacturing location 2 is lower. Click OK. Okay. I was at 2.6 million now with those new production costs. I'm going to click Solve. Okay. Click OK. It looks like I satisfied my demand across the board. It looks like now, instead of not using manufacturing location 5, we're not using manufacturing location 1, which is interesting. Yeah, we went up by 25% on manufacturing costs. I'm going to run Solver a second time. Click OK. And so before, 2.507 million was the optimal, with 60,800 in shipping. Now we're at 2.542 million is optimal, or 67,000 in shipping. So we're incurring more shipping costs because this is now less optimal because some other things changed. We end up with capacity constraint changes. So manufacturer 2 is now right up against its capacity constraints. And we're choosing to use manufacturing location 5 because the cost of manufacturing location 1 went up. Those are the kind of comments I would expect to see. I know this has been a very long video. I normally don't do ones this long, but this is something that quite a few folks came back with lots of questions in prior classes. So I hope me going through this in this much detail has been helpful. Good luck. Please work through the example problem first, and then you are probably going to find that Chapter 10 Exercise 2 and Chapter 10 Exercise 4 are very easy after working through these problems. Thank you very much. Email me if you have questions.